Class, and welcome to the last video in this unit. Okay, it really is section 6.7 if you're wanting to keep in order. However, it is review for test. So we're going to take a look at a warm-up today before we go over all the things that need to be done for your test. However, this is going to be a good review. So hopefully you had some good results on the quiz that you did last lesson. I also will post a second quiz on the website as well as a practice test for you to get ready for your upcoming test. And again, check with your teacher or check the website so that you know when your Unit 6 test is. And a quick reminder, folks, that it's not just Unit 6, it's Unit 4 and 6 that we're going to be testing you on this time. Okay, so number 1 says given this equation, folks, and notice it's in vertex form. Number 1 A says to state the vertex. So remember, your vertex is the P and the Q. Okay, so in this case, your vertex is going to be 3 and 6. All right. Number 2, if you were to graph this function, what would the y-intercept be? And it says to show in 2 different ways. All right. So the first way we remember how to do is method 1, which is just subbing in x equals 0. That's the easiest one. Okay, so we're going to rewrite this equation. Wherever we see an x, we're going to put a 0. Okay, all right, simplify this through, folks, and you're going to have negative 2 times 9. Okay, and that's going to be plus 6, and then you're going to have y equals negative 12 when you're done. That's negative 18 plus 6. Okay, so there's one answer, one way. Method 2 is going to switch it to standard form. So switch to standard, and after you look at standard form, you're going to look for the C value. All right, so let's do that. So if you forget the steps for doing that, check back in your notes, but I'm just going to rewrite the equation first. So I have it lined up here. And then I'll show you the steps and what we do in case you happen to forget. So step 1, follow BEDMAS. You got to deal with the squaring of the binomial. So it's going to be square the first. X times x is x squared. Double the product is going to be minus 6x. And square the last. Negative times negative becomes a positive. Be careful there. And plus 6. Okay. Second step, folks, is your distributive law. You got to multiply a through everything. So y equals negative 2x squared plus 12x minus 18, and then we still have plus 6. And your last step, ladies and gentlemen, is to collect the constants. So y equals negative 2x squared plus 12x minus 12. And again, you're going to say y-intercept equals c value, y-intercept equals negative 12. Awesome. Okay, step 3 says to state 2 symmetry points. So that's either doing fully factoring or partial factoring. I'm going to look at this equation in standard form as we've simplified it, folks, which is right here. And noticing that it's got like decomposition, I'm just going to do partial factoring for my first method. So for question C, method 1, I'm going to use partial factoring, and I'm going to show you the other method if you would like that as well. So method 1, partial factoring. Okay, and again, we've got to use the standard form, ladies and gentlemen, in order to do this. So if I have y equals negative 12x squared plus 12x minus 12, partial factoring starts by letting y equals c, so therefore we'll let y equal negative 12. So it's going to be negative 12 equals negative 2x squared plus 12x minus 12. Okay, we are going to realize that the negative 12s cancel out. So 0 equals negative 2x squared plus 12. I forgot the x there. Sorry, folks. Let me put that in. Sorry, guys. All right. Now we're going to common factor out. Okay, not just a, but common factors. So you're going to take a negative 2x out, and you're left with x equals 6. All right, so our 2 points of intersection or symmetry points that we're looking for occur when x equals 0 for that one, and when x equals negative 6. So therefore, that's a bad looking therefore. Let's see if I can fix that up. So therefore, our sim points are, and remember, we have x equals 0, but we let y equal negative 12. And again, we let y equal negative 12, and our x is negative 6. So there's 2 symmetry points. So folks, just quickly what we did there, I didn't mean to do that twice, sorry guys. So what we did there, folks, is what do we know so far about our graph? We know our vertex is at 3 at 6, okay? We know that it opens down and that it hits the y-intercept at negative 12, okay? So that's negative 12, okay? And our vertex, just in case you're wondering, which we wrote in the question A, is 3 and 6. So we said, hey, we're going to let y, or c, y equal to c value, which is negative 12. So we found those 2 intercept points, okay? Those are, again, 2 symmetry points. Another method that we can use, ladies and gentlemen, is maybe an easier one, which might be more visual. So I'm just going to scoot up here. Okay, and we're going to do method 2, and I don't know why I'm spelling it with step 2. I just want to put method 2. So method 2 is using the vertex and step pattern. Okay, so we know, ladies and gentlemen, our vertex is 3 and 6. So if we go to the left one, that's going to be x equals 2. Then if we go to the right one, that's going to be x equals 4. Okay, all right. But we got to remember our step pattern. So our step pattern, ladies and gentlemen, is a times 1, 3, 5. And in this question, a equals negative 2. So it's going to be negative 2, negative 6, and negative 10. Okay, but as I move over one, I'm just going to follow this pattern. So I have to take a look at my optimal value, which is 6. And if I move over one, it tells me to go down 2. So 6 subtract 2 is going to equal 4 for my y. Sorry, not an x. So my y equals 4. Again, this is a visual thing, and I'll show it down on the graph in a second. And if I have x equals 4, which means I've gone to the right of the vertex one, it tells me to go down. So I'm at 6 and I go down, I'm going to be at 4. So y is going to equal 4. So therefore, these sim points, and again, you can have there's a multitude of answers for sim points. Okay, these sim points are 2 and 4, and 4 and 4. And I'll quickly show you a visual, ladies and gentlemen, on the same graph. So if you take a look at our graph we had here, we're at our vertex, guys. If you were to plot this, you would use the step pattern. You plot your vertex. As you go over 1, you go down 2, which would be right there. So that's the 1 sim point we just found. Likewise, if you go to the right one, you go down 2. So those are the 2 points we just found here. Okay, and not to confuse you, but the point of intersections are the ones we found there. All right, and again, folks, just a quick reminder that the vertex is the only point on a parabola that does not have an equivalent symmetry point. So you could find symmetry points all along here. Okay, all right, and including the zeros, folks. The zeros as well are symmetry points because they're equal distance from the axis of symmetry, which, just as a quick review, guys, goes down the middle. All right, that was a little bit long-winded, I know. Okay, so let's take a look at the last question, D. D says to find the zeros. So the zeros occur when what? When we let y equal 0, because the x-axis, right? Okay, so what we're going to do is we're going to sub y equals 0 and solve. Okay, so we can put in, wherever we see a y, we're going to go 0 equals, and again, use your standard form, folks. Okay, we can quickly see if we can do, to solve, we can quickly see if we can factor. So product equals -2 times negative 12, which is positive 24. Sum equals 12. Ladies and gentlemen, there are not two numbers that multiply to do that, so we can't factor, so therefore we're going to use quad form. Okay, again, quickly spend maybe 1-2 minutes maximum seeing if you can factor. If not, we're going to use quad form. Okay, and if it doesn't specify, just go for quad form right away. All right, so we're going to use quad form. So just in case you forget, guys, A equals negative 2, B equals 12 in this case, and C equals negative 12. So you sub it in. So X equals negative 12 plus or minus the square root of 12 squared minus 4 times A, which is negative 2, times C, which is negative 12, all divided by 2 times A, which is negative 2. Get your calculators out, ladies and gentlemen, and simplify this through, especially the brackets or the, what's under the square root, which is also classified as a bracket. Okay, so plug it in, ladies and gentlemen, and in the square roots, you should end up with 48 here, and your denominator should be negative 4. Okay, split it into its two cases. So X equals negative 12 plus root 48, all divided by negative 4. Okay, plug that one in your calculator, ladies and gentlemen. You're going to get X equals 1.27. Okay. Next one, ladies and gentlemen, says, oh, sorry, the other root, folks. Sorry, I lost my train of thought there. That happens sometimes. So it's a negative 1. Plugged in your calculator, and you're going to get 4.73. Now, ladies and gentlemen, these are the zeros. Okay. You could also have used this and set symmetry points for these. So you could say, these are your solutions for your zeros. So it says, therefore, zeros are 1.27 and 4.73. But you could have used that as well, folks, to find two symmetry points. They just aren't even numbers. So that's why we like to use the partial factoring or the two methods up above, because they give us whole data points. Okay? Technically, these are still your zeros, but they have decimals. All right, so that should be a good review warm-up. Let's take a look at what you need to know now. Okay, and again, come see me if you need any help. Going back to Unit 4, ladies and gentlemen, you have to know relation types. So when is it linear, when's it quadratic, and when's it exponential? And be able to do that if you're given a graph. So a graph of a linear is a straight line. Graph of a quadratic is a parabola. Graph of an exponential is an exponential curve. Okay. You also need to make sure, based on the equation of linear has no visible exponents. The equation of quadratic has an exponent of 2. And the equation of an exponential has an exponent of x. Okay. And last but not least, table of differences based on the first and second, table of values based on the first and second differences. So for table of values, it's linear if the first differences are the same. It's quadratic if the first differences are different, but the second difference is the same. And then exponential, ladies and gentlemen, is when both the first and second differences are not the same. Okay, you also need to remember the key features of a parabola. Where do you find your x-intercepts? Please know all the names for those, meaning zero, solutions, roots, etc. Okay, you need to know the y-intercept. That's your initial start value. You need to know your vertex. You need to know the axis of symmetry, direction of opening, optimal value. That's your q value, or your min-max value. Those are the same. They just have different words. Step pattern, folks. Just a quick remember, guys, step pattern is A times 1, 3, 5. Okay? And symmetry points. Know that there is a variety of symmetry points. Okay? All right, next you need to know all three forms of the quadratic and what each tell us. Okay, so what is the important information? You need to be able to sketch quadratics, and usually you sketch the quadratics using your vertex, P and Q, and then step pattern, right? Okay, or you can just make a table of values, that's fine. You need to be able to tell me when you have congruency, y equals x squared. We spend a lot of time, I want to make sure you guys go over that handout on transformations. So when we shift left, right, up, down, when we flip flip it, or when we stretch it or narrow it. That's based on the effects of A, P, and Q. So check out that summary that we wrote down, and I said study for your test. Make sure you check that out. Make sure you know how to explain the transformations. Okay? I'll do one down below maybe just to go over that because that's been a while since we've done it. Make sure you know how to switch forms. For example, you switch from vertex to standard to find the y-intercept, or you switch from standard to vertex to find the max value. Okay, you need to be able to switch forms back and forth. Okay, next one, ladies and gentlemen, determine the equation when given a vertex and a point. Remember, the key is to find A first. So you sub in the vertex first into the vertex form. You sub in the point x, y, and then the only variable you have left is A. So find A, and then don't forget to sub them all into the equation. Make sure you know the 3 different methods, folks, for finding the maximum value. So one is completing the square, second is partial factoring, and the third one is full factoring, or fully factored form, or full factoring. Okay, and just remember, the partial factoring and the full factoring will give you 2 sim points, and you have to remember that you take those 2, which is s and t, so you go s plus t, and you add them up, divide by 2. That gives you the axis of symmetry, and they take the axis of symmetry and you sub it into the equation to find your q value. Okay, make sure you know how to solve using quadratic formula. I can write that on the board if you need it. I don't expect you to memorize it. And applications. Hey, if it's looking for the min or max, don't forget you're going to complete the square. And if it says to solve for an independent, when did the rocket hit the ground? When was the rocket at 10 meters? Use quadratic formula. Okay? So ladies and gentlemen, please make sure you know what operations to do for your applications. Okay? All the information's been there for you. So what we have today, folks, is we have a practice test, we have textbook questions, and I have another quiz posted on the website, quiz number 2. You can take a look at that. But right now I want to go over a quick transformation review. So just please bear with me, guys, because I think this is going to be good for you. So, transformation review. Okay, so say I give you the equation y equals negative 2 x plus 5 squared minus 10. Okay, and I ask you to explain the transformations. And the transformations, guys, is based on y equals x squared. So based on our basic parabola, which is y equals x squared, what has happened in terms of the transformations? Okay, remember where we in class, we took each letter, we found out how we shifted each letter, we colored a different parabola, and we shifted left, right. That's what we're going to do. So the key is to start off with what A equals. So A equals negative 2. What P equals, and P equals negative 5. Be careful with that one. And what Q equals, and Q equals negative 10. And then you got to tell me what each of these does. Okay, so first of all, we got to take a look at A being negative. So if A equals negative, therefore it opens down. So what you're going to say is it flips down or opens down. So it flips on the x-axis, or reflects the x-axis is another word you might want to use. Reflects x-axis. Okay, all right. That's the negative part. The 2 is that step pattern. So instead of it being 1, 3, 5, it's going to be negative 2, negative 6, negative 10. So we're actually going to make it narrower by a factor of 2. So we're stretching it. So we're going to stretch it by a factor of 2. So it's 2 times as narrow. Okay? So that the A usually does 2 things, the sign and the value. Okay? P, let's take a look at P. P is negative 5. So P does your either horizontal shift left or right. Notice P is negative, so you're going to shift 5 to the left. Okay? And Q, ladies and gentlemen, Q is your up-down movement. And since it's negative, it says we're going to go down, so we're going to shift down 10. So that's how you describe your transformations, ladies and gentlemen. Okay, awesome. There's a good review, folks. You got a day or 2 to do a work period and to get ready for this test. And please come see me if you need any extra help I am available and I'm here to help you. Have a great day, everybody.